So in activity 17, we're going to be talking about algebraic methods. So in 17-1, we're going to be doing some factoring. We're going to factor a difference or sum of cubes, and then we're going to factor higher power polynomials. So we're using a note sheet to go along with this lesson, so have that. It's posted in Google Classroom. Something to write with and a calculator. Okay, so we're going to start with doing sum and difference of cubes. So we have a little acronym we like to use for these, and it's same, opposite, always positive. Okay, a difference or sum of cubes is when you have a perfect cube number, okay, plus or minus another perfect cube number. Okay, if you're not familiar with your cubes, you can always check on your calculator if something is a perfect cube. Okay, but like 8, 27, 64, 125. Those are all kind of our main cubic numbers. Okay. So there's a certain pattern in how these factor. What you're going to do is take the cube root of each of your terms. So whatever the cube root of the first term is and the cube root of the second term. Okay. And when we factor, we put them in this general form. So the A and the B are representing the cube roots of these. Okay. So like A would be the cube root of whatever that first term is. B would be whatever the cube root of the second term is. And then it goes into this pattern. So it's always a binomial, 2 terms, and then a trinomial, 3 terms. So we cube root them, and then it's always going to be A, B. And then in our trinomial, we're going to take the A term and square it. Then we multiply our A and our B terms together, and then we square the B term. Okay? Now, if you notice, the pattern for A and B are the same for a difference of cubes or a sum of cubes. The only difference is the sign changes. So that's where this SOAP acronym comes in. Okay? So for SOAP, I'm going to erase all this. Okay? Our first sign in our factoring is always the same sign. So you know it's minus, minus. This was plus. The first sign is plus. The next sign is always going to be the opposite. Okay? See, I went minus and then plus. Like in the sum of cubes, it goes plus, minus. It's always the same sign, opposite sign. Our last one is always positive. Okay? That plus right there, plus b squared. It's always going to be positive. So if you just kind of remember the general pattern, you can put the sign changes in by using SOAP. Same, opposite, always positive. Okay, let's put this to some examples here and you guys will get the hang of it. All it is putting the numbers in the pattern. We're not really doing any work to factor these. We just have to know how to find a cube root. Okay, so let's look at A. We have x cubed plus 125. So the thing that gives it away as being a difference or sum of cubes is the third power, x to the third power. Okay, when you see that, it's probably going to be one of these factoring types. So what we have to do is we have to take the cube root of each of those numbers. Okay, so the cube root of x cubed would just be x. Okay, the cube root of 125, that would be our b term. Now, if you're not as familiar with your cube roots, you can always put it in your calculator and figure out a cube root. Once we do a couple, you're going to get the hang of and start to remember which numbers go with what. But I'll show you how to do it on the TI calculator. If you use your cell phone or something, there is a cube root option. You just have to turn your phone to the side to get it. But the cube root on the calculator is under the math. I hit the math button and go down to option 4. See, that's this 3 square root kind of thing. That's the cube root. So you'd hit that, and then we just have to type in 125. And we get that the cube root of 125 is 5. Okay, so this is our A and our B term, and I'm just going to plug them into that pattern. So we have a binomial and then a trinomial. So our first term is x, so it's going to be x and 5. That's our A and our B. Maybe I'll write the little pattern above this. And then in our trinomial goes a squared, a times b, b squared. So in my a term is x, so x squared would just be x squared. X times 5 is just 5x. And then b squared, if our b term is 5, 5 squared is 25. Now, if we put in our signs, okay, our original problem, I erase all this so I could see it again. Our original problem was a plus, So to put in my sign changes, it's the same sign, opposite sign, always positive. And that is how you factor a sum of cubes. Okay, so again, it's just a pattern that it fits into. You just have to put the correct numbers in the right spots. Okay. All right, let's look at B, x cubed minus 8. So we're going to start by taking the cube roots of those. So the cube root of x cubed is just x. The cube root of 8, if you didn't know, let's just pop it in our calculator. The cube root of 8 is 2. So my B term here is 2. So I'm going to set up my pattern. It's a binomial and then a trinomial. The pattern is AB, A squared, A times B, B squared. Okay. So filling in my numbers, my A and my B, so x, 2. A squared, so x squared. A times B, so 2 times x is just 2x. And then your B squared. So in this problem, our B is 2. 2 squared is 4. And again, if I put in my sign changes, look at the original problem. So my first problem is the same, opposite, always positive. Okay. And there's our factored difference of cubes. Okay, I'm going to go over one more, and then I'm going to have you guys try D. So in letter C, we have 8x cubed minus 64. Okay, so let's just start by taking the cube roots here. So 8, the cube root of 8 we just did was 2, so this is going to be 2x. For B, 64, let's take the cube root of 64. I get 4. Now, this one I might put the sign changes in first because it doesn't really matter when I do it, but my original problem is a minus, so in my parentheses it's going to be the same sign, opposite sign, always positive. Putting in my pattern, it's AB, A squared, A times B, B squared. So here I go. Just got to put in my numbers. So my A is 2x, and B is 4. A squared, so 2x squared would become 4x squared. 2x times 2x is 4x squared. A times B, so 2x times 4 is 8x. And then always positive B squared. Well, 4 squared is 16. Okay, so again, it's just putting the numbers in a pattern. So for D, you're going to do the same thing. Figure out what the A term is and the B term. So take the cube roots of each of those numbers. Go back to the top of the notes if you have to remember the pattern, but go ahead and put those in. So try D on your own and see what you get. Okay, so for D, the A term, so the cube root of 64x cubed was 4x. The cube root of 27 is 3. So putting those in my general form, that should have been your answer here. Okay. And there we go. Let's go down to these trinomials, okay? So the trinomials, we're going to factor the exact same way we did before. Our answer is just going to be a little different because of these higher powers. So I'm going to factor A the long way, and then we'll talk the shortcut for the rest, okay? So let's look at A. We're going to make the x method. So remember, in the x method, we take our leading coefficient times our constant. So 1 times negative 12. Negative 12. Our B term goes in the bottom, so 1 would go in the bottom. So we need factors of 12, so two numbers that multiply to 12 but add to 1 should be positive 4 and negative 3. Now again, this one I'm going to factor the long way just so we can talk about the pattern we're going to see, but we would start with x to the 4th. If I split my middle term here, now, our middle term is an x squared, so when I split that, this is going to be plus 4x squared minus 3x squared, and then minus 12. So again, the middle term we're splitting. That's why the middle term here is an x squared and an x squared. Okay. Now from here, I can group this. So in my first group, x to the 4th and a 4x squared, they have x squared in common. If I take that out, I have 4 x's. I took 2 of them away, so I'd have 2 left. took the x squareds out, so that just is plus 4. Always bring down your sign in the middle, and then we're off to group 2. 3x squared and a 12. They have a 3 in common that I can take out, leaving me with x squared. Negative 12 divided by negative 3 is positive 4. How do we know we did it correct? Well, my parentheses match, right? That's what we look for. So final answer here, we have x squared plus 4. We bring down our parentheses. They match, so we just bring down 1. And remember, our other factor we get from the outer numbers. So x squared minus 3. We put those together. Okay. Now, when we did trinomials before, we had that shortcut. Now the shortcut still works. If you didn't notice, our answers are still the numbers from the x. But it's not just x plus 4, x minus 3 anymore. Because that middle term was an x squared, your answer is going to be x squared. So you could still use the shortcut. You just have to remember now it's going to be x squared and x squared in your parentheses. So let's do b using the shortcut. So I'm going to set up my x. So it'd be factors of, so 1 times negative 20. And 1 would be in the bottom. So two numbers that multiply to negative 20 but add to 4. What's going to work for this problem? Well, we would have positive 5, negative 4, right? Okay, so I'm going to use a shortcut. I'm going to jump from my x to my answer, just making sure to recognize the middle term isn't a plain x anymore. My middle term is x squared. So your parentheses are going to use x squared. So x squared plus 5, x squared minus 4. Now, with these squared ones, we got to be careful because there could be little extra factor hiding inside of there. Now, x squared plus something we can never do anything with. But be on the lookout for a hidden difference of squares. X squared minus 4, this can be factored again. If you remember difference of squares, we square root each of these. So x and x. Square root of 4 is 2. One factor has a plus, one factor has a minus. And then just bring down this other factor so it's part of your final answer. Okay. And there is our factored trinomial. Okay. So again, you set up the x. The x answers, you should be able to jump to your answer. Okay, you don't have to factor the long way every time. You can if you want. But just remember, in your parentheses, you're going to have x squareds now instead because they're higher power polynomials. And again, look out for a difference of squares. They might be hidden in there. So I'm going to have you guys try c. Okay, it's x squared minus 8x, or x to the 4th minus 8x squared plus 15. So start by setting up your x, and then use the shortcut. Just remember, use x squared in your parentheses. So go ahead and try c. Okay, so here's what I got. Factors of 15 that add to a negative 8 would be negative 5, negative 3. So my factors are x squared minus 5, x squared minus 3. Okay, I'm just going to go through D really quickly. We'll just look at one last one. So I need factors of 36. That would add to a negative 13. So factors of 36, we could use, I think 9 and 4 will work for this one. With both of them being negative, because negative times negative give me positive. Negative plus negative is negative 13. Okay, using my shortcut, I'm going to remember to use x squared. So x squared and x squared. So filling in my numbers for my x, so x squared minus 9, x squared minus 4. The reason I wanted to do this one with you guys is because both of these are a difference of squares. We can break both of these down again, since 9 is a perfect square and 4 is a perfect square. So x plus 3, x minus 3 for x squared minus 9. For x squared minus 4, the square root of 4 is 2, so x plus 2, x minus 2. So before you think you're done with the problem, just make sure you double check. Did you miss anything that you can factor further? These higher polynomials will do that to you. Okay. All right, let's flip it onto the back of this page, and then we'll just do a couple more here. Okay, this is the difference of two squares. So I kind of just went over those on the front page. Remember, if you have the difference of two squares, and it has to be difference, it has to be subtraction, we would take the square root of each of those, and the factors look almost identical, except one factor will have plus, one will have a minus. The only difference with these problems is we have x to the fourths. So when we take the square root, it's going to give us x squared. Let's go through A and B together, and then you guys are going to try C and D. So on A, if I take the square root of x to the fourth, it's going to be x squared. Okay, what times what would be 4 would be 2. So x squared and x squared. What's the square root of 9? Square root of 9 is 3. So we have x squared plus 3, x squared minus 3. Now always check the ones with the minus in case it could be factored further. But since 3 is not a perfect square, we're done with this problem. Okay. Here we go. I'm going to go through one more with you. So 36x squared minus 121. So you notice how those are perfect squares? We can square root both sides. So the square root of 36 would be 6. Square root of x to the fourth is x squared. X squared. Okay, one factor will have a plus, one will have a minus. And then the square root of 121, well, the square root of that is 11. So we have plus 11, minus 11. And that one's done. So 6x squared plus 11, 6x squared minus 11. Okay, so that's all you have to do. So take the square root of both sides. Just remember, if you square root a fourth, it becomes x squared. So try C and see how you do. 9x to the fourth minus 25. Both of those are perfect squares. Okay, here's what I got. Square root of 9x to the fourth would be 3x squared. So 3x squared plus, that should say 3x squared minus. Square root of 25 is 5, so plus 5 minus 5. Right, one last one. Try D. X to the fourth minus 16. Okay, here we go. So x to the fourth, we could square root that. We get x squared. So x squared plus x squared minus. Square root of 16 is 4. So plus 4 minus 4. Just be careful because x squared minus 4 is another difference of squares. So that gets broken down again. Okay. So on these higher power ones, just be really careful. Be on the lookout for when they kind of include extra difference of squares inside the problem. So always just check your answer. If you don't have perfect square numbers, then you know you're done. Okay, but if you have a perfect square with subtraction, it can get broken down again. So that's this, we use the same exact rules for difference of squares. We just have x squareds instead of x's. Same thing with the trinomials. We do the same exact steps we did with the trinomials before. Make the x. Okay, it's just an x squared in your parentheses now. The only thing that's really new and different is this difference in sum of cubes. Let me go back to that really quick. Okay, so they always follow this same exact pattern here. A squared, a times b, b squared. Okay, and then SOAP, same, opposite, always positive with how you put your signs in the problem.